Ports are the lifelines of our economies, moving 80% of global trade. But they are also hotspots for emissions, waste, and habitat destruction, while facing climate risks and other threats. The challenge is urgent, but it's also an opportunity to transform ports into hubs of innovation, efficiency, and resilience. Today, we're joined by experts who will inspire us with practical strategies and success stories on shaping green and resilient ports that cut emissions, improve air quality, and drive sustainable, future-ready growth across Southeast Asia. The webinar begins shortly. Please stay tuned.
Hi everyone, and welcome to our next Green Ports webinar. Ports and coastal infrastructure are on the front line of climate change, facing increasing risks from sea level rise, stronger storms, coastal erosion, and changing sediment patterns. This webinar, Coastal and Port Engineering Building Lines of Defence, will explore how ports can enhance resilience through nature-based, hybrid, and adaptive coastal engineering solutions. Drawing on practical case studies and emerging innovations, the session will showcase how approaches such as living shorelines, eco-engineered defences, hybrid grey-green infrastructure, and beneficial reuse of dredged material can strengthen coastal protection while delivering environmental and operational benefits. Participants of today's webinar will gain insights into how ports can integrate climate adaptation, environmental stewardship, and infrastructure performance to build more resilient and sustainable coastal systems. This webinar is the 8th in this Green Ports webinar series, which highlights how leading ports are addressing environmental challenges and how these approaches can be adapted across Southeast Asia. It is organised by the ASEAN Catalytic Green Finance Facility, which is managed by the ASEAN Power Grid and Special Funds Unit of ADB's Southeast Asia Regional Department. It is hosted by ADB's Southeast Asia Development Solutions Platform and Development Asia. ACGF is an ASEAN infrastructure fund initiative that supports governments in Southeast Asia to prepare and finance infrastructure projects that advance environmental sustainability and strengthen climate resilience. ACGF is owned by ASEAN governments and ADB. Today, we're joined by an excellent lineup of technical speakers. We have Dr. Rebecca Morris. Dr. Rebecca Morris is a marine scientist at the University of Melbourne and is a lecturer in the School of Bioscience. Her research focuses on nature-based solutions for the management of erosion and flooding along the coast. Rebecca will be one of our first speakers, so we will reintroduce Rebecca shortly. Thanks for joining us today. We also have Niels van Kuyen. Niels is a maritime consultant and port planner with a morphology background who has been working on both green and smart ports over the past years. So great to have you with us today or this morning, Niels, and we look forward to hearing from you shortly. We also have Mary Kate Brown. Mary Kate is joining us from Alabama and is experienced in working with a range of federal, state and private entities across the Northern Gulf of America to help implement coastal restoration projects and to leverage additional watershed activities to promote estuarine health and enhance water quality across the landscape. We're very much looking forward to hearing your presentation shortly, Mary, and thanks for joining us. Last but not least, we have Dr. Aziz Mahmood. Dr. Aziz is a lecturer at UTS with a research track record in alkali, activated and geopolymer concrete, rapid set concrete and low carbon concrete in general. And so we'll really bring a very different perspective to balance our webinar session today. So thanks for joining us. We have an excellent lineup of speakers, and I'd like to now introduce or bring Rebecca back to the stage to share her presentation. So without further ado, Rebecca, I will hand over to you.
So my research area is on nature-based solutions for coastal resilience, and that's what I'm going to talk to you about today. So as the video and Jackie explained, ports are critical coastal infrastructure, but their location at the land-sea interface makes them increasingly exposed to coastal hazards, including sea level rise, storms, and changing coastal conditions that results in erosion and flooding. And, this is not unique to port infrastructure, but our growing coastal population and assets and values along the coast. But Protecting our port operations and assets will require approaches that not only reduce risk, but also build long-term resilience under a changing climate. And as coastal hazards increase, we need to start rethinking how we design and manage port edges, moving beyond only using conventional structures that have environmental impacts and are not adaptive, towards trying to integrate some approaches that uses both engineering with natural processes. And so Neil's in the next presentation is going to be talking about the World Bank guidelines for nature-based solutions, so I'm not going to steal his thunder, but just wanted to say that within the families that are in those World Bank guidelines, I'm specifically going to be talking about the wave and coastal dynamics attenuation in my presentation. So I guess more to date, nature-based solutions for coastal resilience have been used more outside of ports, and they're often called living shorelines. And so living shorelines are nature-based solutions that use or restore habitats such as oyster or coral reefs, mangroves, salt marshes, seagrasses, beaches, and dunes to protect our shorelines. And living shorelines are nature-led approaches. So they can be soft, and this is when you just restore the habitat by itself, or it can be hybrid, where there is some engineered component, but the point of these structures is to support the establishment of the ecosystem or enhance resilience. So importantly, the structures become less important over time in providing the functions, and the shoreline protection comes from those natural ecosystems that grow and develop and become self-sustaining. Another, I guess, type of engineering is hybrid engineering, where you may integrate some of these ecosystems, but these are more structure-led approaches. So the structure often has to remain in place and as more of the primary protection part. And of course, beyond this, we can also look at ecological enhancement of traditional infrastructure, which I have worked on in the past, but I'm not going to focus on today. So how do living shorelines work? So they introduce this large-scale roughness into our coastal zone, which attenuates wave energy through drag. It also, decreases the depth, so you get wave attenuation through breaking, and due to reduction in hydrodynamic energy, you get sediment accumulation, but also some of these habitats have these lovely, complex root systems that stabilize sediment. And why would we want to use living shorelines? So not only are they great shoreline protectors, but they also provide a number of co-benefits like food and shelter for to increase biodiversity and fisheries productivity. They can filter water, so improve water quality. We have our blue carbon ecosystems there, like mangroves, salt marshes, seagrasses. And they're also adaptive to changes in climate. So oyster reefs can accrete at the rate of sea level rise. Mangroves have been shown to be able to do the same. But I guess despite the benefits of these nature-based solutions, they're not really used as standard practice everywhere. And through our engagement with our practitioners in Australia, one of the reasons for this is just a technical understanding, what living shorelines can we use, where, when. And so in response to that, we wrote these guidelines. And within these Australian guidelines for nature-based methods, there are some chapters that are quite Australia-specific, like the policy landscape. But there's also a chapter on every single ecosystem that would be relevant beyond the Australian context, and it details what are the kind of physical and ecological considerations for using these nature-based solutions and for optimizing those ecological and engineering outcomes of living shorelines, but also other things that you need to consider, your navigation, safety, what are approvals, governance, other socio-cultural values at the site as well. And I guess to finish in the second half of my presentation, I just wanted to give some examples that I've worked on that might be relevant to the port environment. And so this photo here is from eroding estuaries in New South Wales in Australia. And what I guess the traditional approach to protecting these eroding estuarine shorelines would be to a sloped rock revetment that goes all the way up that estuary bank, and then that would then take up the habitat for mangroves, so mangroves couldn't live on a revetted shoreline. But instead, this approach is called rock fillets, but it's really similar also to rock sills in the United States, where you place a rock structure on a shallow bank platform, leaving some space for mangroves to establish behind these structures. And then the mangroves, provide increased coastal protection through time. And so in systems where you have good recruitment of mangroves, like they do in the New South Wales estuaries, there's a number of mangrove forests there. On eroding shorelines, you get mangroves recruiting, but because the mangroves can't grow their roots fast enough to be able to maintain, so they don't survive past a few months. But once you put in these rock fillet structures, you can see they start to stabilize the bank. You get sediment accumulation, and then you get this recruitment of mangroves behind them. And our research showed that within 10 to 15 years, you get above ground biomass that matches natural fringing mangrove forests in these hybrid structures. I guess the use of mangroves has been done also in port infrastructure in some places globally. This again is the example from the World Bank guidelines of Jakarta Fishing Port, where they've put in a mangrove breakwater to protect their some of their port operations and infrastructure. So the second example that I wanted to talk about are these reef-based infrastructure for reef building species like oysters, or you could also think of corals as well. And so this picture here was actually developed with the Department of Defense in the United States. And so this is at a Air Force base in Florida. And this particular reef was specifically designed for oysters. And you can see, offshore we have these kind of oyster reef patch structures, and then inshore these kind of U-shaped structures are actually to support the development of seagrass, and then the ones even further in the intertidal salt marsh. And so this is to develop a living shoreline mosaic, because we know that when you get multiple habitats together, you have a more resilient coastline. It's more effective for coastal protection, because even when water levels are elevated during a storm, the salt marsh can do more of the work, whereas if the water levels are lower, then the oyster reef might do more of the wave breaking. And also for biodiversity, some organisms need salt marsh and reefs at different stages of their life. And so you need these complex mosaic habitats to increase biodiversity as well. And so this particular module, has lots of surface area for oysters to develop on. When it's not colonized by oysters, it increases drag. As the water passes through the holes. But once the oysters colonize it, obviously you lose that porosity, but it becomes a more rough surface. And so the wave breaking is actually more energetic over these structures. And so you actually get better wave attenuation on lower water levels when you have these oysters colonizing the structure. And I couldn't find any examples of oysters directly in ports, but you can see how you might be able to, for example, integrate modules into the toe of breakwater structures, or in front of breakwaters, or around other infrastructure in ports. That would potentially, I guess, increase the coastal protection of those structures, or reduce the maintenance of those structures. So I think there's probably a few different ways that reefs might be applicable in some areas where you have these reef building species. So to finish off, really, it's just to leave you with what a future port shoreline could look like. And it's really, about designing ports using a spectrum of approaches. So obviously we're still going to have a hard infrastructure in ports, and these could maybe be ecologically enhanced, but, potentially we can have this spectrum of approaches as we move out from the hard infrastructure. and coupling, say, reefs with infrastructure, where nature really becomes part of the system, not just an add-on at the end. And yeah, if you would like any to contact me, here's my email address here. And if you are interested in what living shorelines are being applied in Australia, we've got an inventory online at livingshorelines.com.au.
Rebecca, thanks so much for that. That was an incredibly interesting presentation, and it was great to see what some of the options are out there, both the kind of fully soft to hybrid and hybrid options as well, and really kind of thinking about, you know, how we can apply those in different ways. And I really liked the ability for those kind of mangrove juveniles to kind of grow behind those rock fillets as you described them there. And I think that's definitely something that can be applied in the Southeast Asia region. So really thanks so much for some of those examples, and I guess also noting on that, you know, some of the co-benefits there around the kind of cleaner water, and, you know, a lot of the Southeast Asian regions rely on that for, you know, tourism and fisheries, which, you know, really support those livelihoods. So some great examples there, Beck. Thank you ever so much. And we'll look forward to kind of bringing you back for the Q&A at the end of our session. Just a reminder for the audience, if you do have questions that you would like to ask our panelists today, please use the Q&A function. It is at the bottom of the screen. Any questions that come up, we'll aim to answer during the Q&A session at the end of today's broader panelist session. Next, I would like to invite Niels to join us. So Niels, if you want to jump on and share your presentation with us, we'll look forward to listening. Thank you.
Sure. So yeah, hello, Niels, maritime consultant and port planner at Haskoning. For the past 3 years, I think I worked together with EcoShape and the World Bank on a guideline for nature-based solutions within port infrastructure. So that's the basis of this presentation today. If it continues to click, yeah. So I always find it useful to first really look at the definition of nature-based solutions. So nature-based solutions really embed addressing a problem that we as society have through nature development. And that really makes sure that we align with natural processes, we align with stakeholders, but we also address a challenge that we as society has. So, for example, that has been done already quite a bit in coastal protection, but also, for example, in urban environments. A lot has been experimented with it. But in port environments, that turns out to be still quite difficult. So that's something we wanted to focus on. And it really requires a different way of thinking. And that's what we at EcoShape really wants to do. So EcoShape is a consortium of mainly Netherlands-based companies, such as contractors, consultants, working all over the world, specializing in hydraulic engineering. And we partnered up together with the World Bank to create this guideline. I'll really go quickly through the slides, but I believe they're shared afterwards, so there's more information in there. And you can also always look at the guideline online if you're interested in more information. So, as I said, ports really have a massive impact on the environment. And it could be the natural environment, so they do have an impact on how nature develops, but also they change how natural processes behave around the port. But they also have an impact on the social environment, which is both positive and negative. But they create a lot of jobs, of course, but there are also conflicts with city and coastal squeeze sometimes. The other way around, that's of course also true. So natural processes also require constant maintenance within the port and a lot of additional infrastructure, but also climate change really requires us to rethink port infrastructure. And yeah, and then again, we have a lot of social elements that really also have a massive impact on how a port performs. And we call this the license to operate. And that's one of the important motivations for ports to really consider looking further into nature-based solutions. So what we did with the World Bank is to look at a checklist that you can do when you're considering a port infrastructure development. And by going through this checklist, you can evaluate if there are really opportunities to embed nature-based solutions within your planned improvements. And rather than going through it, I would like to go through it through a hypothetical case, let's say in Southeast Asia. So I have this really hypothetical port and this hypothetical terminal. And I'm really concerned of this terminal because of sea level rise. And I see, or because of climate change, I see risks related to sea level rise and increased storm intensity. And what are those risks? Well, first of all, there can be wave overtopping, which will increase the downtime at my terminal, but they'll also foresee more wave penetration at my berth, which lowers, of course, the productivity of my quay and my cranes. Some other things I have to consider is that I have a limited budget, but I'm also working on really weak, muddy soils here, and I have also other stakeholders which have activities in this area. So the first step in our checklist is really to evaluate really what challenges do I need to address. And these challenges can be really a wide range where nature-based solutions could help you with. So they could be, for example, related to development and expansion. So looking at, for example, CAPEX or operational expenditures, but also looking at permitting or making more use of available space. It can be climate risk related. So think, for example, of storms, typhoons, flooding, sea level rise, etc. But the large element is also performance and efficiency related. The performance of ports is really related to, for example, wave penetration and wave-related downtime, but also navigation performance. Then we have a category which is related to how you maintain your infrastructure, and it can be both soft infrastructure and hard infrastructure. And the last category is really related to that license to operate. How do we deal with the social environment as well, and how do we incorporate them in how we operate as a port? Well, for our case, it's mainly related to climate risks, but also downtime-related risk, wave-induced downtime. If we have identified the challenges that we would like to address, we can consider 4 families. We have divided port-related nature-based solutions into 4 families. The first family is working with coastal systems, so that really relates to what opportunities do reside into working with the natural processes around my port. And this nature-based solution really focus on a system level. Then we have what Rebecca already mentioned, the wave and coastal dynamics attenuation family. So that's really relates to how can I minimize the impact of waves and currents on my maritime activities. And there are many ecosystems that are really well placed to do this. Then the family beneficial reuse of dredged sediment. Many ports have necessary dredging activities they have to do. And this family really relates to, okay, what other opportunities do reside to, what other opportunities do I see to make better use of my dredging activities? And the final family is related to enhancing hard structures. So that's mainly related to how can I make my hard infrastructure, my quay walls, my breakwaters more environmental friendly. So there could be, for example, panels or elements connected or embedded within quay walls or revetments or breakwaters. Can be connected to piled structures, for example. Well, if we look at that case I highlighted, then the waves and coastal dynamic attenuation seems really suitable, right? Because it performs relatively well on minimizing wave-induced downtime. It also mitigates storm damage, and some ecosystems can also grow with sea level rise, so there might also be something there. The next step is really looking at, okay, what other case studies can I find across the world that really relate to my case, and what can I learn from that? So, for example, in a Southeast Asia environment, we can look at reefs and mangroves. And I have this example of reefs in Rotterdam, but there's also this example of mangrove breakwater in Jakarta. And that seems really interesting because it's really a similar case as my hypothetical case, luckily. So what happened here is really a small breakwater needed to be constructed, but it was quite difficult due to the weak soil conditions. So what they did is they reduced the overtopping criterion of the breakwater by using mangroves, a strip of mangroves, to mitigate that wave overtopping. And because of that, the breakwater could be smaller, you need less foundations, and it really resulted in a less expensive breakwater. So I've chosen to do something similar here, a stretch of mangroves in front of my terminal to reduce wave overtopping and downtime of my terminal itself, and also this mangrove breakwater to reduce wave penetration. And I think because of this, also the capital expenditures are a little bit more limited because I don't need to build a fully fetched breakwater, but I can make it a little bit smaller. The next step is go through the 6 enablers, which are related to system knowledge. So how am I embedding this in the system? How do I maintain and monitoring it during the lifetime? How can I make a good business case out of it? How can I embed it into policy and governance? How can I incorporate more stakeholders? And also, how can I strengthen the capacity? So the support from local communities up to board level. And by doing this, probably you need to fine-tune the concept, for example, making the mangroves wider, incorporating more functionalities for other stakeholders. And when you've done this, you can evaluate the full range of benefits, not only for the port, but for a wider range, also looking at biodiversity, carbon sequestration, etc. And when you've done this, it's easier to evaluate a full business case and see if it's feasible. So really in a high level, I think that was what I wanted to show. If you have any other questions related to it, look at the guideline online, but you're also always free to send me an email.
Thanks so much, Niels, for that really interesting and very practical presentation showing the application of those guidelines to a port environment. It was really, really useful. And so thank you so much for that. There are a few questions kind of starting to come through in the chat function, so please feel free to have a look at those and prepare yourself to respond to them shortly, as I'm sure we'll get to the Q&A session. But no, thank you so much for that. It was a great example, and looking forward to the Q&A session in a moment. Okay, so next up joining us, we have Mary Kate Brown. So Mary, if I can please invite you to the screen. Thanks so much. And I'll hand over to you to start presenting.
Yes, thank you. Thank you so much for having me here today. Well, I'm excited to talk about a success story located in the southwest corner of Alabama. This is actually a project that we started in 2016. So it's been 10 years I've been working on this project. And this is a small community called Bayou de Battery. And this is kind of in reference to the small port that we can set an example of nature-based solution. And Bayou de Battery is actually home to multiple seafood processors, multiple fishing families, and shipbuilding. And it's an active working waterfront. This area has succumbed to years and years of hurricanes and also the Deepwater oil spill. But the community has been so used to traditional and being used to the years of coastal storms that they were not really up to nature-based solutions. So this is the kind of a case study of how we kind of were involved in the community to see another point of view. If you see the next slide, it will show you kind of the shoreline erosion over since 1916 with the red line with how the shoreline was before. And over the years, the shoreline just kind of slowly eroded In 1997, you will see that they actually built out the lightning point where the red star is. And then over the next 30 years, the shoreline eroded another almost 200 feet. And so this is really called for action of that we need to incorporate some nature-based solution. So we hired a Marfin and Nickel to come up with some solution with breakwaters, which is the next slide. In 2017, we hired an engineering firm to think about solutions for how do we protect this small port, but also keep an active federal navigation channel, which you can see right in the dark area of the channel. And they do not have previously jetties in that area. So we were actually encouraging the Army Corps of Engineers to allow for a project to have jetties, which is kind of a type of hard infrastructure, but also mix it in with some nature-based, which is coastal marsh and using beneficial use of dredged material. So we moved forward with this project and really looking forward to five different components. This is actually a rendering that Marfin and Nickel did we had it before, and this is what the project would look like in 5 years from now. So in this rendering, we have shoreline protection, which is actually 1.5 miles of breakwaters, rock breakwaters. We also have number 2, which is habitat creation. This is being created using the dredged material. We created up to over 40 acres of coastal marsh, scrub, tidal creek. We also wanted to enhance the public assets. Really, this is the gateway to the bayou. This is where a lot of people come down to fish, not just to take the boat out, but actually fish for food. And then the last 4 and 5 are really focused on the beneficial use of dredged material. We're actually looking forward to actually using locally sourced sediment and protecting the active navigation channel by using the sediment in there and to protect the shoreline of Bayou La Batre. Next slide, please. So here is, we actually were able, after design and getting approval from the state and federal, we were actually able to start construction in October 2019. And sometimes when we do these projects, a lot of times the public doesn't get to see the types of projects that are, in construction, under construction. It's a lot of dirty work, but we actually worked with some really great contractors that were able to understand the purpose and application of dredged material and working simultaneously with building the breakwater. So over the next couple of slides, you'll see the involvement of the project, how we came from dredging the material to build marsh habitat behind the hard infrastructure. And we finished just in June 2020, but right when we were finishing June 2020, the project looked great. We planted. We actually hit a season of storms. We had 4 named storms. Next slide, please. We had 4 named storms in 2020, just when we finished the project. This is very similar to what the Southeast Asian experienced typhoon. And we had 4, like a very active season with 4 storms. And the biggest storm was we received almost 8 feet of storm surge, which is significant. But we knew that our project was able to succeed because there was limited damage on the overall project site. So the next year we waited. In 2021, we have this partner who flies over all the coastal restoration sites, and he really focuses on how the restoration sites change over time. I like this picture because it actually shows you how, like what Becky was talking about, how the nature-based solutions are kind of infusing in with the current infrastructure of like a small port and the community, and it provides a significant buffer that actually protects for flood protection and also coastal storm protection. After 2021, we did experience another storm called Hurricane Ida, and she brought in there was 2 storm surge events that you can see, the 2 peaks in the tidal wave level. This is actually from a wildlife game camera that I posted on a tree to actually show how the project works through storm events. So the first picture, this was like right before the storm made landfall. The next slide is actually when we have the storm surge, water overtopping the living shoreline structure, the whole complex of Lightning Point. And then the last slide is basically at the end when the storm and the water levels recede. As you can see, it looks pretty much the same as it was in the beginning. And this is really proof of concept that these nature-based solutions really do add value and provide a significant benefit to protecting the ports, especially small ports. Next slide, please. So over the years, we were concerned that we were going to have to go back and plant, but as you can see, then over the next aerial through from June 2022 all the way to 2026, we see the site starts to grow into its own, like we expected that it would take up to 5 years. So 2023, 2024, and 2025 with the most, the last aerial. And really you can see that the site has really grown into the whole shoreline and what we really expected. And this is really one of the first dynamic projects that we've done. And we've actually kickstarted a lot of other nature-based solutions using beneficial use of dredge material. Next slide, please. With it, we couldn't have done it without all the partners. So when we talk about from a social benefit, we really have to involve all kinds of stakeholders, whether it's the port operators or the community, the county, municipalities, elected officials, contractors, really respected engineers and partners. Those are really critical in making this a successful project. So it's actually a public trust project. Next slide, please. These are some of the benefits that we were able to kind of calculate from the project. You've already heard most of this mentioned by our speakers so far, but we have reached beyond more than just protecting the shoreline and reducing the coastal erosion. We actually were able to bring in wildlife aspect with respect to the bird species. We used over 240,000 cubic yards of local sediment to build the site. And we created an additional 2.5 miles of tidal creeks and more. Next slide, please. With respect to community, we engage with elected officials and our partners and engage other educators and students to engage with the project itself and understand the benefit after we have completed it. Next slide, please. Beyond the project itself, we're also looking to make sure that the amount of money that we put in these nature-based solutions, which is a highly concern of a lot of people, they are expensive, they take a long time, but in the end, they do triple your benefit when you put in the amount of dollars into it. We're also thinking about the long-term investment into the project as well. Next slide, please. And for example, they are currently building a redevelopment project, which is worth $30 million. So our project would not have been possible, or this project would not have been possible if we did not build the nature-based solution at Lightning Point. Next slide, please. And final thoughts really was critical from this mayor. He was not very interested in nature-based solution, but he simply stated, it's taking what you're working with nature, taking it what is there, increasing it and making better. So that's really I think the biggest point when you talk about infusing nature-based solution to port is understanding what is there, increasing it and making it better for the future. Next slide. Thank you so much, and I look forward to your questions.
Mary, thanks so much for that. That was really interesting to see that time series and that resilience that you've managed to kind of create there as you survived all of those numerous named storms. And I also really enjoyed and recognized the importance of those partnerships and that kind of collaboration with multiple stakeholders in order to kind of realize the benefits of what has happened on that shoreline. So thank you so much for sharing that presentation and those insights with us. I'm very much looking forward to the Q&A session. I think it's going to be quite a tight Q&A session. We do have some questions kind of coming through on the chat box there, so feel free to have a look at some of those in preparation. So next and last but absolutely not least, I'd like to invite Aziz to join me. Aziz is going to bring us a slightly different perspective this afternoon on resilience. And so without further ado, I'd like to hand over and let you share your presentation so we can learn something more about that.
Thanks, Jackie. Thanks for having me into this session. This is more of a sorry. Okay, so this is more of a case study where I have used high-density geopolymer concrete for breakwater armor units, and this project was funded by Cooperative Research Center for Low Carbon Living. And this project was led by UNSW, and the lead chief investigator was Professor Stephen Foster. So to give you a bit of background of the project, this was based on Hudson equation, which typically correlates the individual armor unit, the armor units that we have on top of breakwater structures, which is an inverse cubic relation to the armor density, and also a cubic function of the wave height. Now, with increasing sea level rise, particularly during strong storm events, we have greater wave energy, and it does pose threats on existing breakwater infrastructures that we have along the shores. So this is a summary of the findings that came out of UNSW Water Research Lab, where they have correlated the damage that a breakwater sustains, and they've correlated that damage to a Hudson number. But the interesting fact to look here is with conventional concrete with a density of about 2.3 ton per meter cube, you need to have, and even if the mass of the conventional concrete or the armor unit is downsized to about half, we see a similar level of damage for a typical Hudson number here. So what it means is we can reduce the size of the armor units if we go for a high density concrete. For example, here, this physical model was done with 2.73 ton per meter cube of material density. So this armor unit was made out of a dense material. Now, for this particular case study, there are a number of industry and partners and also government agencies involved, where we've taken the northern breakwater at New South Wales' Port Kembla Harbour, and they wanted to retrofit this particular breakwater with high density concrete armor units. Now, in order to increase the density of your concrete, the most appropriate way would be to substitute your coarse and fine aggregates, that is your stones and your sands, with materials that have a high density. The steel furnace slag, which is a byproduct of steel making, we've chosen that as the material for making our concrete. And if I may go back to the previous slide here, so this site is about 2 hours south of Sydney, and about half an hour drive, we have Australian Steel Mills Services, which produce a lot of steel furnace slag. So this was kind of a locally available material that we could integrate into making the concrete. Now, steel furnace slag has a 20 to 25% higher density than your typical stones, naturally available stones. Australia also generates about 3 million tons of various metallurgical slags as an industrial byproduct. So in the concrete, we're trying to incorporate something that we usually perceive as a waste and convert that into a value-added product. But this particular aggregate comes with a challenge. It has free line, which causes the aggregate to expand when we use that as an aggregate in hardened concrete, and that free line reacts with water in the concrete, and it causes delayed hydration and forms calcium hydroxide, which is a chemically active material, and it also expands with time. So with any kind of expansion within your concrete matrix, it does pose a level of stress that can introduce some cracks within your concrete, and also so deterrence, chlorides and sulfates and carbon dioxide can impregnate your concrete and really hamper the quality of the concrete. So as a solution, we came up with the idea to use steel furnace slag in a low calcium binder. Now, with your typical cement that you get out of cement manufacturers, the calcium oxide content is quite high. It ranges from 60 to 65% if you run a chemical composition of the cement. But we can use geopolymer concrete, which doesn't involve any cement at all as the binder. So we picked fly ash and ground granulated blast furnace slag, which are industrial byproducts as well. So fly ash comes from coal-powered power plants, and slag comes from steel industries as byproducts. So the good thing about these products is that they are very amorphous in structure, so you can activate them using some sort of alkali. So we have chosen sodium hydroxide and sodium silicate to sort of activate. But the key point here is now we are trying to design a concrete which doesn't use any cement, doesn't use any natural sand, doesn't use any natural aggregate or stone. So every component of the concrete comes from industrial byproducts. The only chemical that we used is the activator. Now, this was chosen to allow for the diffusion of free lime into the low calcium matrix due to the high differential in calcium content between the aggregate and also the cement paste that we have, or the geopolymer paste that we have here. The other challenging aspect of geopolymer concrete is the workability. So the property can range from very short setting time to very high setting time, depending on how you design the concrete. And also, the setting time can be a little challenging if you do not have your proportions right. And because this is site application and not within a laboratory environment where we can sort of control the environment, so on site, there's no way to control your environment, and the strength gain was a critical factor in designing the concrete mix. So we were trying to achieve sufficient strength in ambient curing conditions, and we were targeting some markers for the quality of concrete. So we were targeting high density because of what came out of UNSW Water Research Lab, where they have demonstrated that even a little bit of increase in your density can result in a very stable breakwater unit formation. Now, the other aspects were material based. So we were trying to have sufficient workability. So a slump of over 120 millimeter. If anyone within the audience is from a concrete background, you know that workability is an important aspect of concrete delivery and supply and placement as well. We're trying to have a workable time of over 1 hour, taking into consideration for the concrete trucks to come from the plant onto the site, and also pouring and compacting the concrete. The compressive strength is not a critical factor here. The most critical factor is the high density, but we're targeting 32 MPa of compressive strength, so we can move around the high density armor units from the site onto the breakwater. And also we're targeting the diffusion of free lime from the steel furnace slag aggregate into the concrete mix. So the process involves a typical stages of any concrete supply or any next generation or new type of concrete supply. So the lab trials were undertaken at UNSW as part of the project, and we did a trial with a volumetric concrete mixer at Bargo, which didn't go quite so well because these volumetric concrete mixers, they allow about 10 to 15 seconds of mixing time, and with geopolymer concrete, that's not enough time to mix all the components into the concrete mix. Then we went for another trial where we used agitated trucks, and it did really well, that trial. And I'll take you through a bit more information with the trial. After we achieved sufficient strength, we went for the placement of these armor units. So these are geopolymer concrete handbar armor units. Now, these units were placed in July 2018. And since then, we've been monitoring the performance of these units. So basically the material performance of these concrete units. So a bit more into the Port Kembla trial, the steel formworks for the hammer was prepared. You see it's more like a three-legged unit, each of them. And we used a field mix design, which was batched using Cleary Brothers commercial plant, which is about 15 minutes away from the site. And we poured the concrete into two segments. So we filled out the legs first and waited for the legs to sort of stiffen up before we poured the rest of the concrete on the top leg there. So here's a picture of concrete pouring on the top of the formwork. And when they were left within the formwork for 12 to 48 hours. Now, I should give you a reminder that in 2018, these were cast in June and July. So the average temperature ranged from 3 to 10 degrees Celsius. So it's very cold and not an optimal environmental condition for any concrete to reach that level of strength in ambient curing conditions. So when we achieved sufficient strength, these units were placed to with the sufficient strength. What we mean, we collected some samples and took them back to the lab, and we were monitoring the strength development of these concrete cylinders. And when we achieved target strength, we could move around these units and place them onto the breakwater. Here's an aerial view of the geopolymer concrete units. So we made 13 high density, low carbon geopolymer concrete armor units, each with about 17.4 ton in weight. So after 3 years, we went back to collect some core samples and to have a visual observation. So the first thing that we noticed was rust stains on the base of the GPC, on the geopolymer concrete armor unit. So we took some core outs from the site, and we could see the rust stains on the specimens that were collected from the splash zone of the breakwaters. And when after grinding the top bit and the bottom bit, we could notice steel fragments on the exposed specimen surface there. And we also ran comprehensive testing. So I'm just demonstrating here the compressive strength and also the splitting tensile strength here. So with the target 32 MPa, we could see that even after 3 years, the numbers looked very well, and we could see demonstration of continued geopolymerization and also development of strength of these units over time in the first 3 years. The other thing that we were worried about is the free lime associated with the steel furnace slag. So we ran a testing which is ADS. So it's a sort of a spectroscopy, but the main point here is we can see the calcium profile on it, right? And so this bit here is the aggregate, and that's your paste. So initially, after 28 days, we could see a gradient in the calcium profile, which means that from the aggregate into the matrix, the extra or free lime was moving from the aggregate into the paste matrix. And after 3 years, there's a sharp drop of calcium, which means that all the free lime has been absorbed within the paste matrix here. And the dotted line here is the reference for us. So that's on the paste sample only. And we also measured the bulk density of the units. So they ranged from 2.5 to 2.65 ton per meter cube, which sort of ticks all the boxes. So we did achieve the high density that we were targeting for. The calcium diffusion was there, so there's no risk of delayed expansion from the hydration of free lime. We had sufficient workable time to cast these armor units on site, and also we could leave these armor units on site for ambient curing even in cold winter nights. But a few recommendations came out of the durability study after 3 years. So we need our geopolymer concrete to be free from steel fragments. The steel fragments come with the aggregates because these are byproducts of steel making industries. The free lime content, we did recommend that it should be within an acceptable limit of 1.64.4%. The proportion of the slag and fly ash needs to be maintained. So we went for 35% slag and 65% fly ash, and this comes based on 10 different trials, 10 different mix designs of geopolymer concrete mix. And also the research suggests that changing the source and proportion of binder impacts the concrete. So whenever you are doing next batching of your concrete, you should really undertake the material investigation of the source materials if you go for a different source to make your concrete. Now, this project was a large project. I do have to acknowledge all the industry partners. So I've listed them down here. And also the project led to a few publications. So I've provided links for the publications here. So if you have got more questions or if you want to know more about the details of the project, you can go through these links, or you can email me for a copy of the papers. Or if you've got further questions after this session, I'm more than happy to answer your questions. Thank you very much.
Thanks, Aziz, for that really great presentation. It was fantastic to see how it has held up after the 3 years, but also some of the lessons learnt there as well. I'd like to invite all of our speakers to join us back with their cameras on. We've just got a few minutes that we'll tackle some of the Q&As that we've got there. So maybe just sticking with yourself, Aziz, and just briefly, because we are short on time, there's a question around using the cement for the breakwater and the potential for some of the raw oxides in that cement to become available within the local environment. Do you want to just comment on that one for me?
Yeah, thanks, Jackie. Yeah, I just went through the question. So with cement, harmful cement contents for basic raw oxides. Yes, that's right. When we cure concrete, let's say for 28 days to even longer than 28 days, these oxides, they come into reaction with water and they form calcium silicate hydrate and calcium hydroxide, which are the units for giving us concrete strength. So they are not really in a state to diffuse into the water. So if you cure your concrete well enough, and if you make sure that the degree of hydration is above 0.85, then you can eliminate that risk easily. That's
great. Thanks, Aziz. And I assumed that Kembla would have gone through that process to make sure that that was the case for their breakwall. So thanks so much for sharing that.
Thanks, Eleanor, for the question. Yeah.
And yeah, thanks, Eleanor, for the question. I know the team have gone through and answered some of the questions whilst we've been sharing presentations today. We do have a really interesting question that's being posed to us, and I know that a lot of us have been talking about kind of climate change resilience today, and I'm not sure that we necessarily have a response for this, but maybe it's a challenge for us all to kind of take forward and think about nature-based solutions, not just from a climate resilience perspective, but also from a geophysical risk perspective. So thanks, Mikhail, for that question. I think it's something that we all need to kind of take forward and think about after this webinar, unless anyone wants to kind of take that one now. Future task for all of us, I believe. There is one more question here, and we've got a couple of minutes. So just for the broader group, and feel free to pop your hand up or shout out first. Can you share any best practices or international guidelines to prevent environmental degradation of coastal ecosystems? So thinking about those kind of well-established mangroves, salt marshes and coastal reefs that act as that buffer zone, not just to protect ports, but obviously agricultural fields and village settlements from a flooding perspective. And I know we've talked about some of the guidelines available today, but does anyone want to build on that? Flood defense. So maybe just is it more so that the guidelines that we've shared today would be a good place to start in starting to think about how we can prevent that degradation, and start to kind of build on that resilience. I think some of the examples, Rebecca, that you showed with those fillets, the rock fillets being put around as a kind of buffer, to kind of protect those mangrove seedlings and allow them to establish, is probably one good example of that. And so I think Rebecca shared the links to the guidelines that have been discussed today in the question and answer chat. So please feel free to check those out. And we will be sharing our presentations after this session. So if you missed anything or you wanted to kind of check in on a guideline, feel free to jump into the data room. They will be available for people to access. I'd just like to finish off by thanking all of our speakers for their time today. It was really interesting and insightful, and I've loved to see some of those projects as they have created benefits for those environments. So thanks so much for that. We're very much looking forward to our next webinar coming up next month, which again is kind of looking towards that nature-based solutions outcome. So until then, wishing you all a great afternoon, and thanks all for your time.
Thank you.